Hey guys. Alright, so we're going to look more at graphing quadratics, and specifically right now we're going to look at how does the value of the leading coefficient a affect the graph of f of x equals ax squared. So we're going to see what happens when we change the a value right here, and we're going to look at what happens to our graph when that a value is different. Alright, so first we're going to look at f of x equals 2x squared. So we're going to look at what happens when the absolute value of a is greater than 1. So if we wanted to put 2 in, so a is equal to 2. So if I wanted to put 2 in and find the absolute value of 2, well, 2 is just 2. Is 2 greater than 1? Yes. So we're checking when a is greater than 1. Alright, so let's fill out our table. Our vertex is still going to be 0, 0. And remember, that's going in the middle of my table. Then we're going to pick 2 points below and then 2 points above. And we're going to plug them into our equation. So I'm going to plug in first when x is 1. So when x is 1, well, 1 squared is just 1. So I have 2 times 1, which is just 2. So when x is 1, my y is 2, which means when x is negative 1, my y is also positive 2. So now let's plug in when x is 2. Well, 2 squared is 4, so we get 2 times 4, which is 8. So when x is 2, my y is 8. When x is negative 2, my y is also 8. Now I don't have enough room on this graph to graph my x at 2 and negative 2. That's okay. So we're going to I'm going to draw it right on top of this just so you guys can see what happens. So my vertex is the same. When my x is 1, my y is 2. And when my x is negative 1, my y is also 2. All right, so then parallel's going to come up and curve just like this. So if we look at our parent function, f of x equals a x squared, or as we saw last week, f of x equals just x squared. Remember, just x squared by itself is the parent function. So when we look at that in blue, compared to when we have an a value that is greater than 1, we'll look what happens to our graph. Our graph becomes more narrow. Well, now we're going to look at an example. F of x equals 1/2 x squared. So let's look at what happens when our a, the absolute value of a, is in between 0 and 1. So pretty much when our a value is a fraction. Okay, when it's any type of fraction, this is going to happen. All right, so again, our vertex is 0, 0. And we're going to put our vertex in the center. So now we're going to pick negative 1, negative 2, positive 1, positive 2. And we're going to find out what our values of y are for 1 and 2. So first, when my x is positive 1 squared, I have 1/2 times 1. So my y is 1/2 when my x is positive 1. Which means at negative 1, it's also going to be 1/2. So now let's figure out what happens when x is 2. So I have 1/2 times 2 squared. So 2 squared is 4. So we have 1/2 times 4. Well, 1/2 of 4 is just 2. So when x is 2, my y is 2. All right, so I'm going to graph. So again, I'm doing this right on top of this graph. So my vertex is at 0, 0. When my x is 1, My y is 1/2, so it's about right here. So it's going to be about right here on the left. Now when my x is 2, my y is 2, so right here. All right, so we're going to graph out this way. Now I want you guys to look at what happens to the graphs. So before, when my a value was greater than 1, my graph, so my parabola, became more narrow. So it kind of slimmed inward. Well, if we look at the green graph, when we have a fraction, so when my a value is between 0 and 1, my graph actually becomes wider.